So once again, everyone is welcome. We are going to be, we are all welcome for once again to one of our several sessions concerning Solar Simplified meeting that we started a couple of weeks ago. So sorry, we were not able to make it last week as a result of one or two things beyond our control, but I believe we should be able to do something tangible today. And so to avoid any time wastage, let me share what we will be discussing today. Okay. So can you see my screen? These are what we'll be discussing. These are what we'll be seeing.
Not yet.
Okay. Okay. You can see it now?
Yes.
Okay. Okay.
Yeah.
Yes,
That's
correct.
fine.
Seen.
Okay. That's fine. So we shall be talking about,
But make it bolder.
okay, Boulder. Thank you, my brother. Okay. Thank you. I can see. So I think, okay. So is it visible now?
Yes, it's visible.
Okay, if you look at it, we're talking of we'll be talking about steps in solar system installation. We'll be talking we'll be talking on site survey to determine where the PV will be best installed. We're going to also under the first major header, we have four subtopics. The sub topics we'll be talking about: site survey to determine where the PV will be best installed, determination of where the inverter battery setup will be installed, then proper load analysis to determine inverter battery solar capacity, then installation materials estimation, into installation material estimation. So now, the first thing here is site survey to determine where the PV will be best installed. Like we've said in one of our classes, the best position for us to install our solar panels here in this part of the world, or in this part of the world, we are in the northern hemisphere, so is to ensure that our solar panels are installed facing south, they are inclined south facing, you understand, south facing. And they are in most of our installations here, we actually do them on the rooftop. We said it earlier, why we do them on the rooftop is because the rooftop gives us a clear, uninterrupted view of the sun. Well, most of the times we discover that on our rooftops we have a clear line of sight to the sun, so there is no obstruction to the sun. No shadow is formed mostly on rooftops, unless your building is close to a story building or a tower. But most of the times you discover that the rooftop are always the best position to mount our solar panels. Then now, what is the next thing to be considered? Which direction will you install it to have the best sun rays fall on these solar panels? The best direction is south facing. We are in the northern hemisphere, so our solar panels needs to be south facing, needs to be installed south facing. That is, they should be tilted towards the south, and they should be tilted at an angle equivalent to the latitude of the location you are installing it. You understand? If you are installing a solar panel in a particular location and you discovered, first thing you need to do is, okay, I need to know that first thing first is I need a clear line of sight or clear position on the rooftop. If I'm using the rooftop, if rooftop is my option, it should be south facing. Fine. If it should be south facing, then the next thing is inclination angle. Do you see the rooftop actually gives us little or no influence on the tilt angle, because most of the times we follow the pattern of the inclination angle of the roof. You understand? We follow the pattern. We already have a building erected. We already have the roof, unless it was factored in the design that we are going to install a solar panel on this rooftop, then at that point in time, when you're erecting such buildings, you have to factor in the inclination or the slopiness of the roof, so that the slopiness of the roof will give you the best position, best angle to install your solar panels. But most at times, that is not the case, you understand. We actually follow the pattern of the roof. The roof is just the roof, we meet a roof there and we have to follow the pattern. But if you have, if you are to choose a best direction for your solar panels to be installed, please, I always advise, or is always in the best interest of you, the installer or the engineer, to always ensure that your solar panels are installed on the south facing part of the roof. Are you with me?
Yes, sir. We're together.
Okay, that's fine.
Yes, we are together. We can hear you loud and clear.
Okay, so if you carry out a survey, you need to factor in, okay, I have a south-facing side of the roof. That is where I'm going to install my panels. So fine. So if it can accommodate all your solar array, you're good to go. So then next, and I also talked about, should in case you have the, should in case you are the, you will be able to, you are the one to determine the positioning of the solar panels. Maybe the roof south, on the rooftop, there's no south facing direction, or you are given the power or the capacity, you are to determine where it's going to be installed. What you'll do is you ensure that you make your own solar stand to be in such a way that it should be south facing, and it should be inclined, as the slopiness of the inclination angle should be in such a way that it should tally with the latitude of where you are installing it. Typical example, if you're in Yola, for example, I think the longitude and latitude of Yola is coordinates of Yola. Sorry, 1 minute. Let me, I used to have it, coordinates of Yola used to be Yola. So the coordinates of Yola in longitude, coordinates of Yola is 9.2035 degrees north and 12.4958 east. So which one of them is the latitude, please? I want somebody to help us. Which one of them is the latitude? The northern or the eastings? Which one is the latitude?
The eastern is the latitude.
The eastings is the
The
latitude.
longitude is north to south.
The longitude is the northerns or the eastings? Okay, the eastings is the latitude, right? Hello.
Yes, and then north to south is the longitude.
That's fine. That's fine. So in this particular case, the coordinates of Yola being 9.2035 north and 12.4954 east. So we pick the 12.4954 east as the inclination. If you're installing in Yola and you are to it's within your capacity. You actually want to determine you are designing a solar stand or a solar rail or whatever that will enable you up to get the best possible power or harness the best possible power from the sun. You have to make it at an inclination angle of 12.49 something. Around 12 degrees should be the inclination facing south. You understand? That is the best position. You know, one thing is this. You know, the sun path actually changes or varies from time to time, depending on the time of the year, you understand. This thing actually, the sun path actually changes direction depending on the time of the year. So, but with this this particular elevation, it gives you a best position whereby whether the sun moves away, you know, there's a time of the year that the sun comes directly on top of us. Then there's a time of the year that the sun goes away from us. So whether it goes away or it comes directly on top of us, depending on the season, the solar panel should be able to get something good from the sun. That is what it actually means. You understand? So that is what it actually means. So Then next thing we'll be looking at is so the next thing we'll be looking at here is determination of where the inverter and battery setup will be installed. A determination of where the battery and any question concerning where we are to install our solar panels? Any question or addition or suggestion? Or more insight or more addition, because we, just like I always said, it's an interactive class. So please, is there any addition?
Perfect. No.
Okay, so
no question.
So the next thing we'll be talking about is determination of where the inverter battery setup will be installed. The first thing I want us to understand is what is an inverter, what is the battery? We understand what does it actually the inverter, what does it do? We've already talked about that in our previous class. We say it converts direct current to alternating current, you understand? Let's look at the inverter in this case. So basically, the inverter is a transducer that converts energy from one form to the other. You understand? It converts one energy from one form to the other, or electrical energy from one state to the other. So it's a transducer. And basically, from our engineering knowledge, we know that no energy if there's conversion of energy from one form or from one state to the other, there's definitely going to be loss, you understand? So most of these losses are in the form of heat. The same thing applies to inverter system. When it converts from DC to AC, there are losses in the form of heat, you understand? This heat will be generated within the inverter, you understand? So obviously, we should know that the inverter has the ability or has the capability of or let me just put it this way, the inverter generates, the normal operation of an inverter system generates heat, you understand? In the process of conversion of this energy, heat is generated in the system. So definitely you should know that where you're going to install your inverter should be a ventilated place, you understand? It should be what? A ventilated place. You know, most of our inverters are actually, they have chargers and inverters both in one system. You understand? So in one system, you have a charger, you have an inverter. So it converts AC current. When charging, it converts the AC current or AC voltage to DC current or voltage to store it up in the battery. So in the process of doing that, it's also a conversion process. Heat is generated, and in the process of pulling out the stored energy from the battery back to your inverter, back to your power system or back to your load, it also does that, generates heat. So it's a two-way transducer. When it works as a charger anyway. When it works as a charger, it's a two-way transducer because it charges, and it's also, when you are now draining from your source, from your battery bank, it also generates heat. So you should have it in mind that this guy generates heat, you understand? So in the process of generating heat, it means it radiates heat. So you have to install it in a ventilated place. So the inverter needs to be installed in a ventilated place. That's number one. Number two, the batteries themselves. We're going to be looking at the batteries, the common types of batteries we have here in the available within our locality, which is our country as a whole. What type of batteries we use? We have the common one, the tubular. That's the maintenance. That's the lead acid type. You understand? But the wet lead acid type, you understand, which comes in the form of tubular batteries that has liquid as the electrolyte. So that battery actually, in the process of charging, it actually emits, let me not use this thing, it actually emits hydrogen. You understand? Hydrogen, though in minimal quantity, it actually emits hydrogen when charging. You understand? Those of us that are good in chemistry, I believe if you can remember very well the electrolysis, is it electrolysis? I think electrolysis, positive ion, all those things. In chemistry, I can't remember, but basically it's from that electrolysis process that it generates hydrogen, you understand? So this hydrogen, when you will keep this battery in a confined space for long, this hydrogen can actually pile up, and as a result, you know, hydrogen is a flammable gas, you understand? It's a flammable gas, so that means it can actually, the place is prone to risk of fire hazard, you understand? If it gets any ignition, it can actually catch fire. You understand the point? So that is why, number one, if you're using the tubular battery, you need to install it in a ventilated place, please. It actually emits hydrogen, though in little quantity, but when it's in a confined space, it will actually occupy that space, and a little ignition can cause fire incidents. So that is that for tubular battery. So what we can get from there is that a tubular battery needs to be installed in a ventilated area. That's one. Number two, the SLA, that's the sealed lead acid battery. It also emits the hydrogen, this thing, but in a very, very minimal hydrogen gas, but in a very, very minimal quantity. It's actually negligible, you understand? Compared to, you can't compare, but you understand. The SLA, that's the sealed lead acid battery, actually, the emission is very, very negligible. So which means it doesn't actually pose a risk, but what happens if the battery becomes overcharged? Understand? The risk become very high. Its own concern is when these batteries, you know, these things, this setup can actually have an issue with the charging system. And once it becomes, when the charging system becomes faulty, it can actually send a lot of current to the battery. So in such cases, this battery can emit not just the a lot of toxic gases. You understand? A lot of toxic gases can be emitted from a battery, especially the sealed lead acid battery that is sealed. It will emit a lot of toxic gas. So you can imagine what happens if it's in confined space. So you see, I hope you are getting the point, sir. Sas.
Yes, sir.
Okay.
Right on
Yes, sure.
point.
Okay, so that's lovely. So now imagine it is installed in a confined space, and you have an issue with, what do we call it? You have an issue with overcharging. You know what will happen? A lot of dangerous gases would be emitted and in that confined space. So in a nutshell, it's not advisable to install these two batteries in a confined space, you understand, because they need ventilation. The third type of battery we're talking about here is the lithium-ion battery. The lithium-ion battery, the one that we are actually discussing on the type of batteries we actually use here in general. The commonest type of batteries we use here for backup, solar backup or solar inverter systems. The third type of battery I'll be discussing is the lithium-ion battery. We all know it's a new technology. It has high energy density. When we talk about lithium-ion, you know that it's a new technology. It has a longer lifespan. It has thousands of charge cycles, which gives it a longer lifespan compared to the two batteries. And that is why you see a lot of people are craving for it, you understand? The people want it because it's actually has so many advantages, numerous advantages over. We will still discuss about it when we come to determination of battery type and all those things. But it has many advantages that make people crave for it now. So now, what is its own? How do you install it, or what are the what are the possible things you need to look at when installing it, as per location, as per where you want to install it? If you look at lithium-ion batteries they are actually because of the way they are, because of the high energy charge density, they are actually explosive in nature. They are actually explosive in nature, and if they fail, they can actually emit a lot of dangerous gases. So please, though lithium-ion batteries come with a lot of protection, the two types of battery we discussed, they hardly come with protection. But this particular lithium-ion batteries come with a lot of protection. They come with inbuilt battery monitoring systems attached to it that monitors the temperature, that monitors so many things about it. It monitors temperature, it monitors voltages of each cell, you understand. When they are charging, you know, a complete lithium-ion battery cell comprises of so many cells. If you happen to open it, you discover that it has so many cells, 3.2 volts, some come in 3.2 volts, some come in 3.7 volts. They are actually assembled to form a complete system that gives you a high voltage or that gives you the desired voltage you want. So you discover that it comes with a battery monitoring system, which we call the BMS. This BMS actually measures the temperature, you understand? It measures the temperature and sends it the signal to the, it has so many sensors attached to it that measures the temperature, measures voltages, all the indices, all the indices that could be dangerous to the cells. It measures it constantly and gives the, like the CPU, because it has a small, let me call it a monitor or a CPU that constantly monitors it, each cell. So if one particular cell is faulty, the BMS system will definitely will disengage the whole system to avoid explosion. Just like I said, remember, it's very explosive in nature. You understand? It could explode if it fails. So that is why you see all they come with BMS battery monitoring system installed in them that work. If you discover, if you have come across any lithium ion battery that is bypassed, because if they are actually cells that have 333 point something volts. If you decide to connect them in series, you'd get your desired voltage, you power your inverter. If you power it without a BMS, definitely know that you are actually sitting on a time bomb, rather. I would say sitting on a time bomb, because these things can explode when they fail. So any lithium-ion battery system actually should or must work with BMS for safety and everything. So a proper working lithium-ion battery poses no harm as long as the BMS is working, the battery monitoring system is working. Though I cannot say it's 100% ascertained that it's safe, or what do we call it? Is 100% safe, but the fact remains the BMS gives it a very good level of protection, and that makes it, it actually doesn't emit any gas during operation. It doesn't emit any gas during operation, charging or operation, but charging or discharging. But that danger that has to do with explosion is just the major concern, you understand, for lithium ion batteries. So you have to be very mindful of a lithium ion battery must work well with a must work with a BMS for it to be operated safely. So I don't know if there's any question.
We are learning, right?
Yes. Hello.
Yeah,
I
we are
said
good.
we are learning,
Wow.
so right on.
Okay, that's fine. So the lithium ion, that is, the BMS must be working, you understand? And if the BMS system is working well, I believe you're good to go to install it. Though, you know, the battery will definitely be installed with an inverter system. So as you all know, the inverter system needs ventilation. So so it's good to say we should install our inverter and our lithium battery also in a ventilated space. You understand? Since you can't install the inverter in a non-ventilated space, definitely the lithium too that are together with the inverter would have to be installed in a ventilated place. You know, anything can happen. These things are said to be 100%, or we can't say there is nothing that is 100%. The only thing that is 100% as far as we're concerned is the Almighty. So any other thing is not 100% sure, you understand, 100% safe. So if you could actually take some precautionary measures when installing these things, it will go a long way. It will go a long way. So that is that for, in the absence of any question, I think we'll continue. We will be talking next about, we've now known how and where we should install our batteries and inverter system, knowing fully well what they do and how they behave, you understand? So we should now know that if we're going for a tubular battery, we need a ventilated space since it emits hydrogen in little quantity, but in a confined space, this hydrogen gas could actually accumulate and form and become and pose a risk of fire hazard. Secondly, we talked about our less sealed acid batteries. We said what happens, it actually emits negligible amount of hydrogen gas, but what you should be thinking of is if there's a failure in the battery system, it will emit a lot of harmful gases, which will be bad if it's in a confined space. We now went further to talk about lithium ion. We said the lithium ion comprises of various cells that actually the property lithium ion, it's explosive in nature. We talked about it being explosive in nature. So a lithium ion battery system has battery monitoring system that monitors each cell, the temperature, all the dangerous indices of each cells of the battery. It actually measures it, and if it detects any fault or if it detects any fault in any of the cells, it actually communicates to the BMS, which will disengage the battery automatically. So that is a form of safety for the lithium ion battery. So actually the lithium ion battery doesn't emit any gas, but it's explosive in nature. We should have it behind our mind. It's actually explosive in nature. So we should never and never install any lithium ion battery that doesn't have a battery monitoring system. It could explode, you understand? So that is that. The next thing we're going to be looking at is proper load analysis to determine inverter, battery, solar capacity. That is where a lot of us make a lot of mistakes, you understand? That is where a lot of engineers, technicians make mistakes when it comes to solar calculation, load calculation, solar installation. Let me just put the word solar installation. We make a lot of mistakes there, and once you make mistake, you hear issues of this thing doesn't power, doesn't give you the required doesn't give you the desired, you are not getting the desired goal for the installation. So first thing first, I would like to open an Excel sheet so that we can do something there. So coming 1 minute. I'm going to be opening a fresh Excel sheet so that we can start everything from the scratch. Okay. So that we can start everything from the scratch. Okay. Can you see my screen?
Yes, seeing your screen.
So as engineers, we should also, as engineers, technicians, and whatever, we should also be familiar with all these Microsoft applications that make things easier for us. My best Microsoft application is Excel because it makes things organized for me. Yeah, it makes things organized for me and easier. So if I send quotation or I send anything to you, discover that always everything I'm sending to you is in a tabular form, because it gives me, once you see things in table, it gives you a simple, you have a good understanding of what is sent to you. So if you're going to carry out a load, if somebody calls you, a client calls you that he needs a solar to be installed to do this, and this, the most important thing is that this where the person actually needs an alternative source of energy to power his load. So what you do is this. First thing first is, this could be you could write it down on your sheet of paper or on this thing on your, but you could draft it on your notebook, but working with Excel makes it easier. So now, let's take, for example, we went for a survey in a customer premises that needs inverter system to be installed. He said he has, he has loads. We are going to simulate loads here. So the first column, I'll call it load. The second column, I'll call it wattage of the load. Then the third column, I will call it runtime in hours. Runtime in hours. Good. So this is my header for this. So now load. The man says he has television. Television. He has, let's say he has a big television and a small television. I'll call this one big television. Big television, the wattage is 140 watts. This one is wattage is in watts. Wattage is in watts. Are you with me? Wattage is
Yes, sir. Yeah.
wattage is in watts. Runtime, that is the hour of usage per day. The hour of usage per day. So he runs this big TV. He says, okay, I run this TV for 6 hours. Then I have a small TV in the small parlor. TV in a small parlor that has a wattage of 70, and that one runs for 5 hours in a day. Good. I have fans, the cumulative fans normally run simultaneously. Cumulative loads on the fan. Okay, let's be discreet. Fan number 1, I have 25 watts, and it runs. That's the fan in the living room, fan number 1. It runs for 12 hours. The fan in the bedroom, fan number 2, that's bedroom 1. Fan, let me remove the S, because since we're discrete and we want to talk about individual items. So fan number 2, the same 25 watts in the room. If I come into sleep, I on it for, let's say, 8 hours. Then the fan in the children's room, fan number 3, the children's room, it's also a 25-watt fan. It also, let's say, it runs for lesser hours, 6 hours, since it's children. So we have lighting points. Light points. We have lighting points. For lighting points, you can only take average, because you some lights, when you enter a room, you're on the light, you off it. So you can just take an average for the lighting. Lighting, we have you take lighting, you summarize the total wattage of the lighting, 5 watts, 10 watts, blah, 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 blah. By the time you sum all of them, you have, let's take, for example, 220 watts, and you assume an average, okay, an average of 8 hours these lights run per day. The next thing is, let's say he has a refrigerator. It's 220 watts, and he wants it to run for 18 hours in a day. So he tells you that this is what he needs to power. You understand? This is what he needs to power, and this is the total hours he needs. This is the hour for each item. Each item runs for so number of hours. The next thing you do now is to determine